So today we're looking at integers in Task 2 in Standards Algebra. Now remember, if two numbers have the same sign, so if they're both positive or both negative, then the product is positive. So here's an example. So if they're both positive, their product is positive. So an example would be 5 times 3 equals positive 15. If A and B are both negative, then the answer is also positive, because negative 5 times negative 2 is positive 10. So in other words, if A and B have the same sign, their product is always positive. If they have opposite signs, then their product is always negative. And that's what this chart shows. A positive times a negative is a negative times a positive is a negative, and so on. Negative times a negative is a positive. So here's an example. 6 times negative 4 is negative 24. Okay, now if A is 0 or if B is 0, their product is always 0. That's the zero product property. So in our examples, we're going to find the product. So first of all, we decide whether it's going to be negative or positive. A negative times a negative, they have the same sign. We know that's going to be a positive 16. Here they have different signs, so we know it'll be a negative, and it's a negative 18. Here's a you try. Go ahead and pause. 6 times 6, and we know the product is positive because they have the same sign. And you try this one. Go ahead and hit pause. Okay, 8 times 0 equals 0 because the product of anything with 0 is 0. Okay, dividing integers, we have the same rules. If A and B are both positive, the quotient of A divided by B is positive. If they're both negative, the quotient is positive. So an example would be 6 over 3. They're both positive. Their quotient is positive. If A and B are both negative, negative 10 over negative 5, their quotient is positive. Pardon my left hand getting in the way there. So in other words, if they have the same sign, their quotient is positive. If they have opposite signs, then just like with multiplication, the quotient will be negative. So in that case, negative 15 over 3 equals negative 5. If A equals 0, A divided by B is 0. But why can't B be equal to 0? You can't ever have 0 in the denominator because it is undefined. Denominator. Okay, I'm going a little fast here because I don't want this video to be too long, and because you have the ability to hit pause if you need to go back and look at something. Okay, so we're dividing a negative by a negative. That means it's going to be positive because they have the same sign. Positive 2. We're dividing a positive by a negative, different signs, so the result will be a negative 3. You try. Go ahead and hit pause. Okay, they have different signs, so the result will be negative 4. Go ahead and hit pause. All right, they have the same sign, so the result will be positive. Now we're turning the page over. Adding more than two integers. We'll be looking at order of operations next time. With order of operations, when you're at, you go from left to right. And in task 3 we'll be reviewing that. I would guess that you guys have already seen that. But that's the way I'd like to approach this. I'd add the first two numbers first and then add the third. So if we add the first number to the second number, that's 3 plus negative 11. And remember, if you need to, you can use your number line. Positive 3 means we go to the right 3. Negative 11 means we go to the left. 4, 5, 6, 7, 8, 9, 10, 11. Oh, that's negative 8. And then we have plus that 5. So negative 8 plus 5 is negative 3. I can use the same method, or I could use the method that we looked at in task 1. You could use 8, write down 8 negative signs, 8 minuses, and that one's a little messy, and 5 pluses for your 5, for your positive 5. Those cancel and you're left with 3 negatives, so it's negative 3. Okay, now let's try without the number line. Negative 19 plus 18. You can even picture a number line in your head. That would be negative 1 plus negative 4. So we've added these two together to get negative 1, and then we still have our negative 4. Combined, those are negative 5. If you need to pause and use the plus and minus method or use the number line, go ahead. Now you try. Go ahead and pause and give it a try. Okay, so negative 2 plus 5 is 3 plus negative 11. 3 plus negative 11 is negative 8. 4 plus negative 15 is negative 11. Negative 11 plus 10 is negative 1. Okay, now we're looking at exponents. A power is an expression that represents repeated multiplication. So if you have a power like this, and the whole thing is called a power, this number is called the base, this is called the exponent. This tells you how many times we're repeating the multiplication of this number with itself. So there are 4 3's being multiplied in this case. So let's look at 2 to the 6th. The power is the entire thing, 2 to the 6th. The base is 2 and the exponent is 6. Okay, 10 to the 4th, the power is 10 to the 4th, the whole thing. The base is 10 and the exponent is 4. Now, bear in mind with 2 to the 6th, that is 2 times 2 times 2 times 2 times 2 times 2. 10 to the 4th is 10 times 10 times 10 times 10. Okay. And just some vocabulary. We can say 12 to the power of 2, or we can say 12 squared. We can say 4 to the power of 3, or 4 to the 3rd power, or 4 cubed. Now we are going to evaluate powers. So up here we just showed what we call the expanded form, where we showed the actual multiplication. Here we're actually going to find a number. So 2 to the 5th is 2 times 2 times 2 times 2 times 2. There are 5 2's there. Now, you can work from left to right. 2 times 2, if you evaluate the first multiplication first, this gives you 4 times 2 times 2 times 2. Then I can evaluate my 4 times 2. That leaves 8 times 2 times 2. And then I can evaluate my 8 times 2, 16 times 2, and that gives me 32. Another way to do this would be to group these. That's 4, and that's 2 by itself. You could say 4 times 4 is 16 times 2 is 32. So there's several ways to do this. Now, what do you think 10 to the 1, 10 to the 1st power is? Now, go ahead and pause your computer and try the U-try. Okay, so this is 4 times 4 times 4. There are 3 4's.